The James Webb Space Telescope, JWST, often referred to as Webb, is a groundbreaking instrument that has provided stunning insights into stars, planets, galaxies, and other extraordinary astronomical phenomena. It has set new standards for scientific exploration and discovery, building on the legacy of the Hubble Space Telescope. Since its first image of the universe was revealed, a year has passed, and the JWST has continued to astound the global scientific community with its remarkable detail and new findings. One of the most recent revelations from the James Webb Space Telescope is an unprecedented image of the universe, offering details never seen before. While the discoveries made so far have raised as many questions as answers, they have undeniably sparked ongoing discussions among scientists. As we delve into how this telescope captures the most awe-inspiring images ever seen, it's clear that the replacement for the Hubble telescope has uncovered new information about star formation, planetary collisions, and the early universe. Just 1 month after its initial release of photos, JWST revealed stunning images that offered a deeper look into the universe, showcasing intricate details of distant stars and galaxies. The number of discoveries has continued to grow exponentially, with JWST providing researchers with a wealth of data to explore. The telescope has documented remarkable objects such as massive nebulae, supernovae remnants, and stars on the verge of exploding. Thanks to its advanced technology, the telescope allows scientists to peer farther into space than ever before, unveiling previously unknown details about the cosmos. This marks the beginning of a new era in astronomy. To commemorate its first year of operation, NASA released an image of a star-forming region in the Yuki cloud complex. This image captured the gas and dust being emitted by baby stars, creating vast, colorful clouds that illustrate how new stars are born. The red dust shown in the image is made of atomic hydrogen, and the shadows cast by the circumstellar disk suggest the possibility of planet formation in the distant past. NASA described this star-forming nursery as relatively calm and small when compared to others, with many of the young stars in this region being about the size of our own sun or even smaller. Interestingly, this star-forming area is the closest to Earth, and the image was captured using the telescope's near-infrared camera, which captures images in 2 distinct infrared wavelengths simultaneously. In addition to providing detailed views of the universe, JWST has also advanced our understanding of exoplanets, or planets that orbit stars beyond our solar system. In early 2023, the telescope discovered its first exoplanet, Algis 475b, located 41 light-years away with a size similar to Earth's. JWST's ability to analyze the atmosphere of Earth-sized exoplanets is unmatched by any other telescope, making it a valuable tool for future astronomical research. JWST's remarkable precision was also demonstrated when it detected evidence of ancient galaxies that, from a theoretical perspective, should not have existed. Researchers at Swinburne University and their international collaborators discovered 6 massive, ancient galaxies, dubbed universe breakers. These galaxies, thought to have formed between 500–700 million years after the Big Bang, challenge previously held theories about the early universe. According to calculations, galaxies from that time period should have been much smaller, but these 6 massive galaxies are millions of times more massive than our Sun, with some having stars that are 100 billion times heavier than our Sun. The discovery of these enormous galaxies has left researchers puzzled. While most galaxies in the early universe were small and growing slowly, these universe breakers reached maturity much faster than expected. The finding challenges our understanding of how galaxies formed in the early universe and could radically alter how we view cosmic evolution. This revelation also raises questions about the nature of large galaxies in the early universe. These discoveries may force us to rethink many of our assumptions about cosmic history. Spectrometry, which separates light into its component frequencies to measure distances more accurately, will be needed to confirm the results, but the early findings are already causing a stir among astronomers. While the results are still being analyzed, the fact that massive galaxies have been found so early in the universe's history could imply that the process of galaxy formation was far more rapid and complex than previously thought. The future of space exploration looks incredibly exciting, as JWST continues to uncover mysteries that challenge our understanding of the cosmos. The perception of reality has long been a topic of interest for researchers, And it is no surprise that the advent of advanced telescopes, such as the James Webb Space Telescope, JWST, has led to conflicting realities that challenge our understanding. This has prompted a need for greater clarity in interpreting cosmic discoveries, especially as the JWST reveals evidence of galaxies that appear to have formed or evolved much earlier than expected according to current models. Dr. Katie Mack, a renowned cosmologist, has shared her insights on this issue, helping to explain the reasons behind these discrepancies. Dr. Mack pointed out that the JWST has been capturing images of galaxies over 13 billion light-years away, which, while incredibly distant, still appear somewhat unclear. The problem arises because these galaxies seem to have developed much earlier than what scientists had anticipated based on existing cosmological models, which are primarily based on the Big Bang theory. For instance, the fact that galaxies exist at such immense distances in the universe suggests they may have formed before the expected time frame. However, Dr. Mack reassures that the telescope's images are not definitive, and that further investigation is needed to understand whether these early galaxies truly challenge current models. The clarity of the JWST's observations is affected by the nature of the light it detects. The telescope employs spectrographs to spread out the light emitted by distant objects, and filters that allow only specific wavelengths of light to pass through. This helps astronomers determine the redshift of galaxies, which is essential in estimating their distance and, consequently, their age. Redshift refers to the stretching of light as objects move away from us, and its measurement can provide a snapshot of cosmic history. However, the images captured by the JWST are not always sharp. Galaxies often appear as fuzzy blobs, which is due to the effect of redshift on the light spectrum. The higher the redshift, the more distant and less clear the galaxy appears. In some cases, these distant galaxies have an abundance of stars, or stars that are too young, which further complicates the understanding of their formation. There are several explanations for this, including potential misalignments in the telescope's calibration, or the fact that the models used to interpret galaxy spectra are primarily designed for nearby galaxies and may not apply well to more distant ones. Another intriguing possibility is that these observations might force cosmologists to reconsider some foundational aspects of the Big Bang theory and the role of dark matter in galaxy formation. If these distant galaxies are indeed much larger than expected, it would challenge the idea that the universe developed in the way we thought it did. The JWST's revelations are not limited to galaxies. Researchers have also been startled by the discovery of a planet that is considered too large for its host star. This planet, which is about 3 times the size of Earth, is located in a planetary system around the ultra-cool red dwarf star LHS 3154. This discovery challenges previous assumptions about planet formation and the types of stars that can support large planets. The fact that such a massive planet can exist around a star with only a fraction of the mass of our Sun was previously thought to be impossible. Yet, this finding suggests that our understanding of planetary formation and the architecture of planetary systems may need to be revised. Ultra-cool red dwarfs, which are smaller and cooler than our Sun, were not expected to have enough material in their protoplanetary disks to form large planets. However, this new evidence points to the possibility that planets may emerge from the dust and gas surrounding such stars, even though the expected conditions were thought to be insufficient. Just like adjusting the position of a person around a fire to stay warm, a planet must orbit closer to its star to maintain enough gravitational pull to keep its orbit intact, especially when the star is cooler and less massive. This discovery prompts scientists to rethink their models of stellar and planetary evolution. Planets with sizes up to 3 times that of Jupiter have been found orbiting other stars, but the existence of such a massive planet around a low-mass star was considered highly unlikely. As we learn more about space, it becomes clear that our understanding of the cosmos is far from complete. In conclusion, the more we explore space with advanced telescopes like the JWST, the more we are forced to reconsider our preconceived notions about the universe. Discoveries like these challenge the assumptions that have long been central to cosmology and planetary science, suggesting that our current models of the universe might be far more complex than we ever imagined. The James Webb Space Telescope, JWST, is currently observing Europa, one of Jupiter's moons, for signs of activity beneath its surface within our solar system. As a Galilean moon, Europa has long been considered one of the most likely places for life beyond Earth. Despite its icy exterior, scientists believe there is a vast underground ocean beneath its surface. The ice shell itself is fascinating, with surface cracks and a turbulent, cold environment, and it even emits large plumes of water vapor. These plumes are believed to originate from the ocean beneath. Researchers will examine Europa's surface properties and chemical composition in detail using JWST's infrared capabilities, providing an opportunity to search for the chemical signatures of life. The JWST will focus on the plumes emerging from the surface, and should they find intriguing chemistry, it would mark the first potential signs of life on Europa. Many unexpected results are anticipated from this mission, further enriching our understanding of this distant moon. The JWST, often referred to simply as Webb, has revolutionized our understanding of the universe with its remarkable observations of stars, planets, galaxies, and other celestial phenomena. Celebrated as the successor to the Hubble Space Telescope, JWST has provided the scientific community with an unparalleled tool for exploration. People around the world are sharing its images and analyzing its raw data to generate new insights. Since its first major image was released just over a year ago, the JWST has continued to amaze astronomers with its detailed observations. One of its latest images, a breathtaking view of the universe, has left researchers with more questions than answers. A month after releasing its initial images, the JWST provided new insights into star formation, galaxy mergers, and the early universe. These images were striking, offering unprecedented clarity. Since then, JWST's discoveries have multiplied, revealing an immense treasure trove of data. Some of its reported observations include infinite tarantulas, record-breaking space smoke, stars on the edge of cosmic explosions, and other extraordinary celestial objects. Thanks to its cutting-edge technology, the telescope allows us to peer deeper into space than ever before, uncovering hidden details about the universe. To commemorate the first year of JWST's operation, NASA released a captivating image of a star-forming region within the Large Magellanic Cloud Complex. This image shows jets of gas emanating from infant stars amid large, colorful dust clouds. The red dust, made of molecular hydrogen, casts shadows on nearby stars, indicating the presence of circumstellar disks that might point to potential planet formation. While the scene appears chaotic, NASA describes this stellar nursery as small and tranquil compared to other similar regions. Many of the young stars in this area are about the size of our Sun, making this the closest star-forming region to Earth. Captured using JWST's near-infrared camera, the image showcases vast scenes in two distinct infrared wavelengths simultaneously. Additionally, JWST excels at studying exoplanets, worlds orbiting stars other than our Sun. It has made significant strides in observing distant exoplanets, such as its discovery of LHS 475b, located 41 light-years away, in early 2023. This planet is similar in size to Earth, and JWST is the only operational telescope capable of analyzing the atmospheres of Earth-sized exoplanets. This finding highlights the telescope's precision and opens a new frontier in exoplanet research, particularly regarding rocky planets. JWST has also identified ancient galaxies that, according to theory, should not exist. A team led by Dr. Evo Lab of Swinburne University and colleagues discovered 6 massive old galaxies, dubbed universe breakers, which could change our understanding of space. These galaxies are believed to have formed between 500–700 million years after the Big Bang. With JWST's infrared sensors, we are able to peer back roughly 13.5 billion years, revealing much older stars and galaxies. The enormous size of these universe breakers has puzzled researchers, as early galaxies were expected to be much smaller, typically 10 to 100 times smaller than these findings. These galaxies could be billions of times heavier than our Sun, with individual stars potentially weighing up to 100 billion times more than our Sun. This discovery challenges our understanding of galaxy formation in the early universe. Dr. Joel Leah, an assistant professor of astronomy at Penn State University and co-author of the study, expressed his astonishment at the discovery of this new class of objects. This finding suggests that large-scale galaxy formation occurred much earlier than previously thought, challenging established scientific theories. While further spectrometry is needed to validate these results, the fact that the spectra match predictions based on visual observations is promising. If these findings hold true, it could mean that galaxy formation was much more efficient and rapid than we previously believed.